We're starting into chapter 2 here, and again, we're going to move through rapidly. We're going to do sections 1, 2, and 3 in one session here. Section 4 and 5 we'll do as one. Section 6 I found usually needs a little more attention, so we'll just spend one session on that one section, and we'll finish up 7, 8, and 9 in one session. So here we go, zooming through chapter 2. Let me get my color for my pen. Okay. We're going to solve equations which contain fractions or decimals. This is actually going to be very useful to you. What we learn here you can apply throughout the rest of your studies of mathematics, I guarantee you. It'll be a way to make such equations much simpler. Equations which contain parentheses, just have to remember to deal with parentheses first. And using the principle of zero products. This is a biggie. You will hear me for the rest of the year referring to the zero product property. This is extremely useful. Here's a little review of what we've already been working on. Probably pretty simple for you. We're going to multiply a fraction times an integer. Well, let's think of it as a fraction times a fraction, because any integer could be expressed this way, correct? In multiplication, unlike addition, in addition, we have to worry about common denominators. In multiplication, no such concern, because we are going to look at this as both the numerators multiplied together and both the denominators multiplied together. Now you're probably noticing, as I am, that we've got 7 over 7. Which we know is equal to 1. 7 divided by 7 is just a fancy 1. Then we end up with 3 over 1, which we would express as simply 3. In the case of fractions which are being added together, now we have to consider whether or not we have like terms. So as soon as you see an addition sign or a subtraction sign, you need to be thinking of like terms, whether they are fractions or not. But when they are fractions, like terms means that their denominators are identical, which is not the case here. However, we can make them identical, can't we? We're going to look for the least common denominator, which is 4. This one already has 4, this one does not, so what are we going to do? We're going to multiply it by a fancy one, namely 2 over 2, which will give us 2 over 4 plus 1 over 4. Now please notice, when we're adding, we get that common denominator, and that's what we use. We don't do anything else to it. Once we have that common denominator, we leave it just like that. Where we're going to do our work, our addition and our subtraction, is in the numerator. So very different from multiplying fractions. Now how about this one? All right. The coefficient is going to multiply times the number here, which will give us 355. The x, remember this is multiplication, we do not have to worry about like terms. The x is still there. That's our answer. So just remember the difference between multiplying factors together and adding terms together. Very different. Techniques that you can use when you have a decimal. Clearing the equation. It's very useful. What does that mean? That means we're going to get rid of the decimals altogether. In the case of this one, what multiplier would you use to get rid of all the decimals? Well, you could see here that we could use 10, and that would give us 2,140x plus 214x equal to 2.14. Now I think I would stop right there, and that's what I would use. I wouldn't try to clear this one. The reason I wouldn't try to clear this if it's decimal is because I would have to multiply this whole thing by 100 again, and then I'd have really big numbers here. I think that clearing this decimal has made it easier for me to add these two together. And that's, you could take it further. Take it as far as you need to take it in order to make it work for you. What multiplier would you use to simplify this? Here we're going to be looking for least common denominator in these fractions, which would be what? Okay, 16 I hear, which means I'm going to have to multiply this by something because its denominator is not 16. This one's already okay, and what about this one? I'm going to need to multiply that by something as well. This will multiply by 1, yes, but what's that 1 going to look like? 8 over 8. Good. And this one? 2 over 2. Now there's some good news here. I'm going to have 8x plus 3 equals 10. This is over 16, and this whole thing is over 16. I'm not even going to bother to write it in, because if I multiplied this whole thing by 16, what would happen? As long as I do the same thing to this side as I do to this side, they stay equal. So here is a really helpful thing to know about equations with fractions. Find your least common denominator, multiply your whole equation by that, and you end up with 8x plus 3 equals 10, and it's going to be simple to solve after that. All right, these techniques, this is what we're going to practice. We're going to practice clearing the equation and finding the least common denominator. That's going to help us in clearing the equation. Here we've got fractions. We don't want to work with fractions. We're going to clear it. So what are we going to multiply by? The least common denominator, which is 14. When I multiply this by 14, what am I going to have? 14 divided by 7. 2z. When I multiply this by 14, the 14s will be just a fancy 1, and I'll have a 3. Same thing on this side. So I end up with 2z. I'm going to subtract 3 from both sides. Okay. This one, of course, has decimals. Ugh. And they are confusing. They really are. It's a lot easier if you're dealing with integers. So what would you have me multiply this by? To clear the equation of decimals. Yeah? I agree. That looks good. So if I multiply 0.5 times 100, basically I'm saying 1/2 of 100, aren't I? What do I get? Or you could think about it this way. I'm going to move this decimal point 2 places, and I end up with 50a plus, move that decimal 2 places, 75a plus, move that decimal 2 places, 120 equals, move that decimal 2 places, 145. These can be combined. This I'm going to subtract from both sides. And my equation will then look like this. 125a equals 25. Good. Now I won't subtract. I'm going to do the opposite of multiplying, which is dividing. And I get a is equal to yes. So for solving equations, I'm going to give you some guidelines right here. You might want to put these in your notes. First of all, you will usually want to remove parentheses. It isn't always true, but whenever you've got a situation like this, where the variable you're solving is inside the parentheses, you definitely are going to want to use the distributive property to remove them. Clear fractions or decimals, we're practicing that. Collect like terms so we can simplify each side, and then use the addition and multiplication properties of equality to solve for the variable. I've got x trapped inside this set of parentheses and also over here. So this will become 15 plus 10x, that's right. Nothing needs to be done to the 12. It's a positive 12. Then I'm going to multiply a negative 4 times x and a negative 4 times a negative 6. That's right. That's sharp of you. That's right. It's going to be a positive. Okay, so we used the distributive property to remove parentheses. Clear fractions or decimals. We don't have to worry about that in this case. Collect like terms. Okay. Well, on this side, well, let's start over here. This side, these are not like. Remember, to be like, they have to have exactly the same variables at exactly the same power. Well, these have different, this one has no x, this one has an x. Those are unlike. But here we've got two like terms, these numbers. They can be added together. I'm going to rewrite this with 10x first, plus 15. What did I just use? I used the commutative property of numbers, of addition, right? And now if I add these two together, what happens? I get 36, right? So I'm going to have a negative 4x plus 36. I am now going to use the addition property of equality, which says if I add a negative 15 to both sides, these equations remain equivalent. It's still a true equation. So 10x equals negative 4x. Remember, when I have a positive of something and a negative of something, when I combine them, I get 0. Negative 4x plus 21. I'm going to use this. Let me scroll this up a minute. Just a little bit. We're doing number 4 right now. I should have checked that off. We did this one, collect like terms. We're working on this one right now. Use the addition and multiplication properties. I'm still going to use the addition property. What I'm going to do is I'm going to add 4x to both sides. 4x plus 4x. What that does for me is this becomes a 0, and I have 14x equals 21. Now I'm going to use multiplication property. What would I multiply this by? 1 over 14. You may prefer to think about this as, okay, I'm going to undo the multiplication by dividing both sides by 14. Or you can think about it as I'm going to multiply by the reciprocal of 14. Either way works. So here we get a 1, and I have x is equal to 3 over 2. This is a correct answer, but it will not give you full credit. To get full credit, you want to simplify it. Okay, let's see if we understand the zero product property. It's going to be important for you to understand this. I love the name of this thing because the name of it tells you exactly what to do. You need to have a 0. We'll talk about where that 0 has to be. And you need to have a product. That is, you need to have something being multiplied by something else. If x is equal to 0 and y is equal to 0, if we multiply those together, do we necessarily get 0? Yes, we do. If x is equal to 0 or y is equal to 0. So now in this case, the second case, one or the other, but not both. Must this be equal to 0? Yes, anything multiplied by a 0 is equal to 0. If x times y is equal to 0, is it true that x is equal to 0? Maybe. Is it true that y is equal to 0? Maybe. One or the other. So when the question is, must one or the other be equal to 0, your answer is yes. Excuse me. Okay, so here we have, remember I said the name will help us out, we have the 0. This is where the 0 needs to be. On one side of your equation you have a 0. On the other side of your equation you have a product, two things being multiplied together. That's true here. Here's one factor and here's the other. We know that either this or this must be equal to 0 for their product to be equal to 0. So here's where we make what I like to call the mini equations. We take these factors, a minus 3 and a minus 1, and we set them equal to 0. Now I'm going to use the addition property of equality. A equals 3, or A equals 1. We just used the principle of zero products. This one looks a little more complicated, but if you look at it from the upper level, it's exactly the same. We have the 0, we have one side equal to 0, and we have the product. Here's one factor times another factor, definitely a product. We're going to set up our mini equations using the two factors. Oh, that's weird. Here. Let's clean that up a little bit. We're going to set those both equal to 0, because if when they're multiplied together they equal to 0, then one of them must be 0. I'll use the addition property of equality. On both of these now I'm going to use the multiplication property of equality. If I multiply this by its reciprocal, 1/2, now as long as I do it to both sides, and do the same thing here, except, oops, not 1/2, this time 1/3, or you may think of it as divide both sides by 3. Okay, the zero product property, that's so important. Using equations. Anytime in this book that you see this word using, think word problems. So what we're going to do in this little section is we're going to translate the words into equations. This is the little process that's outlined in your book. Understand what the problem is. So read it and make sure you understand what the question is. Then plan. That's most of your work. Then you solve whatever your plan is, probably solving an equation. And finally, don't forget to check your answer. We're going to go quickly through a mess of these. Twice the number n. What we're doing here is we're practicing how to read these things. Oh, twice the number x. I'm sorry. I guess I can use a little work on my reading. So what would that, how would we write that? Now, notice we're talking about an algebraic expression, not an algebraic equation. Equation is when we say something is equal to something else. In these 8 examples, we don't say that they're equal to anything in particular. We're just trying to come up with a way to convert this from words to an algebraic expression. Is that the same as twice the number x? Yes. 5 more than n. When you see the than, I recommend that whatever follows it, write that first. Then n. Go ahead and write the n. Then go back and read this again. 5 more. Fewer than w. So let's start with the w and go back and say, okay, 7 fewer. The total. This is one of the things that attracted me to math when I was your age. This is such a nice shorthand. This says it without all these words. Okay, up here in number 5, 8 less than, remember my hint here, look at the than and write down what comes after it. 8 less would be this, right? 40% of B. Remember that percent means 40 per 100. Those of you who are studying Latin, cent, centurion, century, 40 per 100. And we want to convert that into decimal. 0.4 times B. The of is the same as times. The average, now we have to remember what average is. It's the sum divided by the count. Average is the sum divided by the count, which in this case is x plus y, that's our sum, and how many are we adding together? 2. So that would be how we'd express that one. That's a little trickier. 1/3 of z. And I recommend that you keep the fraction. Don't try to convert that into decimal, because you'll lose accuracy if you do that. The giant economy size of wheat whiffles is 25% larger than the regular size. Okay, so we've got the cereal, and then we have the giant economy size, which is a little larger, 25% larger actually, right? The giant economy is 500 grams. How large is the regular size? So if we say this one is X, we can say that the giant size is 0.25. It's actually 1.25. Whoop. Oh, come on. It's 1.25 times x. It's as large as x, that's the 1, plus 25%. That makes it 1.25x. How large is the regular size? Well, if the giant economy is 1.25x, and I also know that the giant economy is 500 grams, I can solve for x to find out what the regular is, which means I need to divide both sides by 1.25. When let me pull over my calculator, and we'll turn it on. When I divide 500 divided by 1.25, I get 400. So I get my regular size is equal to 400, and I should pay attention to the units, grams. Does it make sense? Well, if this is 500 and it's 25% larger than this, it does make sense. Okay. The sum of two consecutive even integers is 50. What are the integers? Well, one of the things I know about even integers, 2, 4, 6, 8, is that they, and if they're consecutive, the next one is always 2 more than the one before. So if I say x equals the smaller integer, then x plus 2 must be the next integer, right? Those would be the 2 consecutive even integers. Is can always be used for putting together an equation. This is equal to 50. If I add up x plus the next integer, x plus 2, it will equal 50. I'm going to combine like terms. I'll have 2x plus 2 equals 50. If I, at this point, use the addition property of equality, I will subtract 2 from both sides. 2x equals 48. X is equal to, what have I done? I'm using the multiplication property of equality. I'm going to multiply both sides by 1/2, or divide both sides by 2, 24. So I know the smaller one is 24. The question is, what are the integers? It's not asking me to find only one, so the integers must be 24 and 26. Now, does it make sense? You say it does, and it does. I've assigned problem 27. This is a really challenging problem. Here are some notes on it. I'm not going to go over them now, but I just want you to keep in mind that that is available here. So if you think you might like to have those notes, go ahead and write them down or come back to them. We're going to finish up here with solving formulas. First of all, let's look at this, the influence of cats on modern physics. We have this lovely little tabby over here influencing this mathematician working on physics. We're going to solve formulas here, and the reason we even talk about physics in your science courses, you're using formulas quite a bit. So it is important to be able to solve them. Write each of the following statements as an equation. This is just a little warm-up for us. The circumference of a circle with a radius r is, there's the equals, 2 times pi times r. You know this anyway, right? But here it is in words, and we translate it into a formula. The area of a rectangle with width w and length l is the product of width and length. Now don't let the and fool you here. This is not adding, is it? This is the product of. So this is telling you we are multiplying these two together. You have to read carefully. You knew it anyway, but I'm just emphasizing how to read these problems successfully. The area of a triangle with a base B and height h. So we have a triangle, and it's got a height of h and a base of b. Its area is 1/2 the product. So again, the product. These are going to multiply together. B and H. These are all formulas that you may find useful in this section. Whoops, sorry about that. To solve this equation for R, what would you need to do first? What I recommend to my students is keep your eye on the prize. What is it that you're trying to solve for? Trying to solve for R. You can't get to it. You can't get to it. Why? Because it's trapped in these parentheses. What do we do in that case? Distribute to get it out of those parentheses. So the first thing you would do is distribute. Let's pause for a moment and think, what is a formula? It's a rule that we use for some specific calculation. I'm going to go back thinking about that right to here. If we want to know the circumference of a circle, this is the rule we use. Multiply the radius times 2 pi. If we want to know the area of a rectangle, this is the rule we use. We multiply the width times the length. If we want to know the area of a triangle, we multiply, you might think of the width times the length, but we call it now the base times the height, and we take half of it. Let's solve this formula for W. Well, remember what we said, we were going to keep our eyes on the prize, which is right there. We are going to want to focus on this W. How do we get it all by itself? Right now it's being multiplied by L, length, so we do the opposite. Instead of multiplying, we are going to divide both sides by L. When we do this, we end up with this is equal to 1. We get W is equal to area divided by length. How about this next one? Put our eyes on the prize. We want to solve for X. Ooh. Now, X is trapped in here, isn't it? So let's distribute. We'll get W equals 3x minus 6. Now, keeping our eyes on the prize, which is X, that's what we're trying to solve for here. We have something being, we have a negative 6 being added to this, right? So we're going to add a positive 6 to both sides. Then we will have W plus 6 equals 3x. We're trying to get x all by itself, so we're going to divide both sides by 3. Get x is equal to W plus 6, all of it, divided by 3. Finally, we want to solve this one for R, so let's point out what we're looking for. Well, this term is the only one that has R in it. So I guess I could subtract P from both sides, couldn't I? And I'd have A minus P equals P R T. Now I've got my r times p and t. So let's divide both sides by p, t. This becomes a 1. This becomes a 1. And I end up with r equals a minus p divided by pt. Complete. We'll say completed. Okay, so bring your notes and we'll move forward in class.